Good afternoon, all of you. Today we shall read about the critical angle. So, what is critical angle? Basically, this phenomena is related to the refraction of light. Let me tell you. Let's say this is the separation of a media, okay, and the denser medium is here, and the rarer medium is here. I'm taking its refractive index as mu1 and its refractive index as mu2. So what we shall do? Let's say a ray of light is incident on it. So what will happen? We know when a ray of light is incident on it, it passes through like this, as it is going from denser to rarer medium. Now let's say the ray of light is incidenting like this, so it will go like this, and if the angle of incident is more than that, it may just go like this. That's mean along the separation of the media. Okay, now I am just drawing this phenomena here. That's mean this is the separation of media. I am drawing a normal. This is the denser medium, this is the rarer medium, and a ray of light is incident here, and after refraction it is passing like this. And here let's say the angle of incident is I and the angle of refraction is R. The refractive index of this media is mu1 and the refractive index of this media is mu2, as we told previously. Okay, so this angle I am taking it is at theta c. This theta c is the critical angle. When it is critical angle? When the angle of refraction is 90 degree. Look at this. Here the angle of incident is theta c when the angle of refraction is 90 degree. But in this case, this angle of incident is not 90 degree. This angle of incident is not 90 degree. But this angle of refraction is not 90 degree. But this angle of refraction is 90 degree here. So R equal to 90 degree. So for which angle of incident angle of refraction is 90 degree, that angle of incident will be called the critical angle. So here theta c is the critical angle. Okay, now I shall apply Snell's law here. Snell's law, how to apply? We know mu1 sin I equal to mu2 sin R. mu1 is refractive index of this medium and I is in this medium, so they are together. Similarly this is also. So mu1, instead of I shall write theta c, as I equal to theta c I have taken, and instead of R I shall write 2. So mu2 sin 90 degree, instead of R I shall write this. So sin theta c equal to, I can write mu2 by mu1, and sin theta c equal to sin 90 degree equal to 1, I know. Okay, so what about theta c? So theta c equal to, we can write sin inverse mu2 by mu1. This is the formula. Okay, from here we can do a specialized case. So special case. What is the special case? Let's say the medium mu1, its refractive index is mu. Any medium, it can be any medium except air. Any. And medium 2, let's say this is the rarer medium, I am taking this as air. Okay, so mu2, the refractive index of air is 1, so this is air. Now what about this formula? We can write theta c equal to sin inverse, instead of mu2 I shall write 1, and instead of mu1 I shall write mu. So this is the formula, theta c equal to sin inverse mu. Is it okay? And this theta c is known as the critical angle. This is very important for numericals, but you have to keep certain points in mind. What are that points? To obtain the critical angle, light must have to go from denser to rarer. What is the condition? Light must have to go from denser to rarer. Light must have to go from denser to rarer medium. The opposite process is not possible. Okay, denser to rarer medium. Is it okay? And the angle in rarer medium, if the angle in denser medium is 90 degree, then we shall call it the critical angle. Is it clear? You have to solve numericals. Okay, wait for the next video.